Assalamualaikum and good morning. Bismillahirrahmanirrahim. Let me start with the topic related to software testing. And you can actually refer to chapter 8 of Ian Somerville textbook. Okay, what will be covered? So this video will be broken down into several parts. Basically, it will be covering on different stages of testing, which is development testing, um, release testing, user testing, and then we'll come back to test-driven development. And lastly, we'll cover on testing principles. Okay, just to give you some overview, what is related to software testing. In this slide, it is referring as program testing, where when you do testing, it is meant to show that what the program does. Okay, what we want to check that the system that have been developed is developing the functionality or the non-functionality that the users are supposed what the users want. Okay, so let's say the user want 10 functionality. So we during testing we have to ensure that all that 10 functionality have been developed. Okay, and on top of that, testing is used to discover program defects. Okay, not only that, the system has all the required function needed by the user. We want to make sure that any kind of errors or default or system that might crash is actually uh, we have eliminated before we actually put it into use. Okay, before we release it to the user. Okay, when you do testing, sometimes the system is not fully ready. Okay, so you'll be using some artificial data. So you make your own data. Okay, and sometimes in order to reveal the program defects, you will be running it using all sorts of data that is not it which is meant to reveal the error. Okay, so you check the results for any test run that have revealed error, anomalies, meaning thing which is not certain, and also you check for the information about the program non-functional uh, attributes. Okay, not only that, we check on the functionality part, we also check for the non-functionality requirement that we have covered before, right? So when you do testing, you can reveal the presence of error. That's the purpose of testing. You want to find fault. Okay, what make the system crash? Okay, if you put data which is not the usual data, you see whether the system crash or not. How does it react? Okay, but when you are doing testing, you are purposely want to show the existence of error. But even though you keep on testing it, there are also some parts of the in the program that you might not be able to reveal the error. So that's what it means that so testing is not to show the absence. Okay, even though you keep on testing, there are still some parts of the testing which there are some parts of the program that there are still some error there which is not being revealed. Okay, testing is part of general verification and validation process, which includes static validation technique. Okay, let's have a look to see the definition of verification and validation. Um, Coming to the purpose of doing program testing, what are the goals? Okay, basically, there are two goals that I have mentioned earlier, but I recap it again in here. The purpose is to demonstrate to the developer, those who do the coding part, the programming part, and also the team of developer, and also the customer, that the software meets its requirement. So this is what I mentioned just now, that when you build a system, you want to make sure that you are developing what the what have been agreed in the requirement, functionality and non-functionality requirement. You have to ensure that that is being met. Okay, on top of that, the second purpose of this testing is to discover situation in which behavior of the system is incorrect. We want to identify possible error that might happen when certain inputs have been put in, okay, certain processes, steps that have been executed in the system. You want to see whether is there any undesirable action that might be triggered by the system. Okay, so that's where this term comes in, which is called defect testing. You want to actually reveal any possibility of error that might happen. So when you do defect testing, you are trying to identify the root. You want to identify, you want to remove the undesirable system behavior, such as system crash, unwanted interaction, maybe the system freeze without, or maybe the page does not move, you cannot move it to the home page, for example, or maybe incorrect computation, wrong formula, you input certain data, different results are appeared on the screen, and also maybe when you want to save the data is corrupted. So that is all the thing that might go wrong. Okay, so you will keep on hearing this in the introduction session, so that you get the main point of doing the testing. Okay, so I mentioned just now, to meet the user's requirement, non-functional and functional requirement, and secondly, to reveal error, all sorts of error. Okay, coming back to the thing that I mentioned just now, when we want to check whether the system performed correctly, and you need to you can do that, okay, by writing a set of test cases. So test cases is like steps on what to test, how to test it. Okay, that is test cases. Okay, so when you want to do testing, you need to write a set of test cases, so that you know in advance what need to be tested. Okay, so these test cases need to reflect the system expected use. Okay, I've mentioned just now, the purpose of doing testing is to ensure that the system actually perform correctly based on the user requirement. Okay, so that what it means, and this kind of action is called validation testing. And secondly, I mentioned just now, when you do testing, you are basically trying to find a defect, and that comes defect testing here. And to do defect testing, you still have to write test cases, right? So you write, okay, what to test, what page to be opened, what input to key in, okay, what results should be appeared when certain data are being keyed in. Okay, that is test cases, and these test cases is written in order to expose the defect. So you'll be putting data, um, and you are trying to perform the steps which is not normal to the system. Okay, the first one is just to make sure that everything goes well according to the requirement. The second part here is to is another testing strategy that is meant to reveal the error. You put wrong data, you execute wrong processes. Okay, so just to expose the error. Okay. So this is coming back to what I've explained just now, validation testing, to demonstrate to the developer and subsystem customer that the software that they have been built is actually meeting its requirement and operates as intended. Defect testing, on the other hand, is the opposite, which is to discover fault and defects, right? Where you want to reveal the behavior which is incorrect and non-conformance with its specification, right? And successful tests is a test that makes system perform incorrectly. Okay, so when you do testing, defect testing, I mentioned just now, you are purposely trying to break the system. You want to expose uh, the fault in the system. So it is trying to basically you want to crash the system, okay, and you want to break the system. Just to introduce you with some terms when you are doing software testing. Okay, just now you see defect, right? So defect. So actually, the origin of before it you reach defect, it actually started with um, root cause. Root cause is basically the origin, the starting point where the defect or failure can happen. Okay, it started with the root cause, and then because there are some problem in the beginning, so and then it leads to error, and then it leads to defect. So it might be shown in the system, wrong calculation, and then failure. Failure is the results, the end results when something goes wrong. Okay, so as an example, for example, there are whenever there are some defect, defect and failure after the end of the software testing phases, the test manager will try to identify what actually caused all this from happening. So they will go and trace back and investigate, and uh, from there sometimes and they will identify the actual cause of the error. So for example, let's say failure happened. For example, incorrect amount calculated is shown on the screen. Okay. So and then when they go and check, oh okay, wrong formula are being used. Why does this happen? Yeah. So actually it happens because the developer is making a wrong assumption. Most probably maybe the developer did not understand the actual calculation when he read through the specification, and then if you go and trace back, why does this happen? This is because the system analyst, where during this discussion with the customer, uh, might capture the requirement unclearly. Maybe because the system analyst does not understand it thoroughly. Okay, so those are what will happen, and how does it when they do investigation, they will identify what is the root cause. So when they know this has happened before, so the system analyst will be more alert when doing discussion with the customer during the requirement engineering, so that they actually capture clear requirement. Okay, just to give you some general idea what happened during testing. Okay, so imagine this is your system. Okay, so you basically write test cases. Test cases I've mentioned just now is basically steps on how to perform the test. So if you want to, normally for each of the requirement that you identify, you have one or two, maybe several test cases, and then test cases normally comes with the data. Okay, so for example, I want to test a login for a online system, for example our UUM online system. Okay, so of course I will put in the username, a correct username and password, and on top of that I also will put input that cause anomalous behavior. I will also put data that will test the system. Okay, I will just want to think all sorts of way to crash the system. So maybe I do not put any username or password at all. Maybe I put a very long username, okay, password that is using lots of symbol and so on, just to see how the system react. Yes, if I put a combination of data that is not normal, and then I put it into the system, I run it during the testing, and then I want to see what is the output. Does it crash? Does it give you wrong message on the screen? Okay, so that is what will happen. Okay, coming back to this term verification and validation. Okay, so when you hear somebody say we are doing verification on the system, so what it means is that it is trying to check whether the system conform to its specification. Okay, you heard about it just now. One of the objective of testing is to ensure that the system being developed actually meeting or conform to the specification. That is verification. The other term which is also related when you are doing software testing is that there's another term which is called validation. Okay, validation is to ensure that the system do what the user really requires. Okay, verification is just is like ensuring that the system is meeting the remember you have a list of requirement and non-functional requirement, right? So verification is ensuring that you are meeting all the requirement in the checklist. Validation, on the other hand, is let's say the system is ready, you let the users use it. Okay, so you ask the user to use it, see whether the user uh, feel that the system is actually what they want. Okay, right, this is validation is to ensure that we are meeting the you can imagine verification is that you are meeting this schema. Let's say if you have an exam, I have a schema, right? So when you answer it, I'll check whether are you meeting my schema or not. On the other hand, validation is that the ready system you give it to the user. Maybe sometimes the user does not agree with the system because during the requirement engineering, the requirement was not captured in a proper way. Okay, so that might happen during validation. Okay, validation is done by the user and it is purposely to check to ensure that the user uh, that we are developing a system based on what the users want. So normally we call it V and V. Okay, V and V is to establish confidence that the system is fit for the purpose. Okay, so you are not only that it is following what is being agreed between the user and the developer, but it is also what the users want. And all these depend on the system purpose. Okay, what is the purpose of the system? What is the user expectation? And also the marketing environment. Okay, sometimes let's say some of the system being developed is not all in the stage it's not a critical system. Maybe sometimes some of the functionality is just to support the management, for example, so it might not be too critical. Okay, so maybe the level of V and V is slightly lower. Okay, um, maybe the user have low expectation. Okay, so as I mentioned just now, if the system purpose is not too critical, maybe the user expectation is slightly low compared to system. For example, if let's say the organization is changing to a new financial system, okay. Of course, when you do financial system, you need to be accurate. You need to um, be ready on time to support the other department and so on, right? So maybe in that purpose, in that situation, the user expectation is slightly higher. So in that case, the V and V is maybe put into more focus. All right. Okay. So let's come to a term which is related to verification. I've mentioned that we are doing verification and validation. Let's look at the first type, which is verification. Verification, I've mentioned just now, is done to ensure that the system being developed is conforming to the requirement. Okay, so verification can be done through software inspection. That's one method. The second method is software testing. So you keep on hearing software testing just now, right? So 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 coming to the verification stage, so there are two types of method that you can use. First one is software inspection. The second one is software testing. So software specification is said to be static verification, where you analyze the system manually to discover the problem. Most of the time it is done manually, but there are some tools also to help. So you can imagine software specification like a teacher the checking your homework. Okay, it is done manually. Maybe there is some set of schema that the teacher is using, okay, to check whether you are doing it correctly. So inspection is done. It is said static verification because you don't have to run the system. So you simply look at certain documentation. Okay, on the other hand, uh, also on verification, but dynamic verification, okay, it is another form of checking, which is in this slide, we call it software testing. It is concerned with exercising and observing product behavior. So this one here, you actually run it. You run the system where you put in some data and you see how does it behave. Okay. So just to see the linking between inspection and testing, where both are actually verification, uh, is done during verification phase. Okay, when I mentioned to you, inspection can be imagined like a teacher checking your work. So this is like inspection. You inspect the requirement specification. You normally do inspection on some documents. Okay, you can also check it on coding sets of program written by the programmer. You can check the database schema, the UML diagram that you might create, maybe the software architecture. Okay, so once it is in the runnable form, okay, you can perform testing, because testing is more dynamic. Dynamic means that it is performed on a system which is can be executed. Okay, software inspection. Software inspection, I've mentioned just now, it involves people. People doing what? Examining the source, all sorts of documents that you have seen just now, to discover anomalies and defects, to check any possible uncertainties, okay, which is not consistent, and also possible defects. Sometimes actually you can find defects even through the documentation. Okay, uh, inspection does not require execution of the system. It does, even though the system is not ready, you can still do it. Okay? So it'll be checking on any source of representation of the system, design, any design document, any configuration document, and on also test data. Okay, and it is actually quite effective in discovering errors. Okay, a good thing about performing inspection is that actually when you do testing, when you run the system and then you put some data in, sometimes there are errors, but there are actually that error is caused by other errors. Okay, so that is what it means by this statement. During testing, errors can mask or hide other errors. Okay, so when you do inspection, you're actually checking the codes one by one, the codes, and then you go and check it back against the requirement. Okay, so by doing that, you can actually identify the error earlier. Okay, you can perform inspection on incomplete version. Okay, even though it's not fully ready, you can still run it. You can still check it, and then the good thing about inspection is that this is manually done by experts normally, maybe senior programmer in your organization. Okay, so it can check against compliance with standard. So this part here is related to the non-functional requirement. So check against standard that the organization might have to follow. Any portability, whether it is meeting the portability, non-functional requirement or maintainability. Maintainability can be achieved because when you do inspection, you can go and check the codes. Okay, you want to show whether that codes is actually following object-oriented principle. Okay, is it being written such a way that it can be extended later on, right? All right. Let's look at inspection and testing. Okay, both of these are normally done uh, together. Okay, it depends on the company purpose. Okay, if if they have the budget and time, and based on the system criticality, so it can done um, together. Okay, it's not against one another. You normally done together, or you do one of it. Okay, depending on the budget, okay, and the purpose of the testing. Uh, as I mentioned just now, inspection can check conformance with a specification. But inspection does not check conformance with the customer real requirement. This is when I say real requirement that is related to validation. Okay, inspection is verification method. So, right. So inspection cannot check all non-functional requirements. You can check for, I mentioned just now, can check for standards, can check whether it is portable or not, but it cannot check against non-functionality requirement related to performance, usability. So why this cannot be checked? Because this has to be done um, by running the system. Okay, so due to that reason, inspection cannot check some non-functional requirement related to this performance, usability, and so on. Okay, let's have a look what happened when you do, what are the processes involved in software testing. So there are actually many diagrams. If you go and check, there are many ways on how to represent this. So this is according to Ian Somerville. So when you want to test, actually this is only partially processed. Okay, you start by designing the test cases. I mentioned to you, test cases is more like steps on how to execute the testing. What kind of data that you want to put in, what are the steps that you want to follow for that particular test case, what will be the results, okay? And then you prepare the data. Okay, what data that you want to use during the test cases. For example, we want to test login uh, function. Okay. So you need to put all sorts of user name and password, which is correct, which one is uh, not normal data. Okay, just for the purpose of crashing the system. And then you run the program, the system together with the test data, with your test cases. Okay, and then you get some results. Then you compare the results that you get during the testing. Is it the same like the one that you have written in the test cases? When you write the test cases, you also write the expected results uh, for that particular test data. Okay, well, if you put correct test data, of course, for the purpose of login, it bring you to the main page, right? Let's say if you put the wrong data, maybe if the system allow the user to test for 3 times, okay, so you want to see that the system is behaving like that. So when you run the test, you actually compare back whether what you get is actually the same like what is being stated in the test cases. Alright, so I did not explain this. Okay, when you do test cases, when you write test cases, you get test case, and then you give it here, and then you try to identify the test data, and then when you run, you get test results, and then you do comparison, and after that you actually do to the report. You want to see how many test cases show pass or fail. Okay. Um, so we have to look at inspection, one of the method in verification, and we have come across and have looked at the process just now related to software testing. Alright, software testing itself, there are actually many stages, and actually there are many types also, but for this slide we only cover on the stages. You can do it during the development when the system is being built. You can actually perform testing already to discover bugs and defects, and normally this is done by the programmer. And then when the system is ready, okay, it is in the release testing stage where this is performed by a separate testing team. So this is not done by the developer anymore. It is done by another team to test the complete version of the system. Okay, now the system is ready, so it is done. The testing is done by somebody else. Okay, just to have some because when it is done by somebody else which is not involved in the development, of course they have a different view, right? So maybe there are some errors that might not be discovered during the development testing can be identified here. All right, so this is done before the system is released, is given to the user. Okay, after that, so this is the user testing. So at this point of time, the tester are the user themselves or the potential users, where they test the system in their own environment. So all these are done, development team, development testing, release team are done in the system development offices or organization. This one here, user testing, is done in the uh, user's office using their own computer and servers. Okay, to summarize this video, let us recap what we have learned so far. At first, if you still remember, we have looked into definitions and the goals of performing testing, software testing. Even though there's lots of discussion that's happening, the main core thing that is covered is from the aspect of validation testing and also defect testing. So whereby when we perform testing, we are trying to achieve validation testing, where we are actually trying to ensure what have been developed and what the users want is matching with one another. And secondly is that we want to identify possible errors or defects in the system, so that all the errors or behavior which is incorrect has been identified before the system is being released. Right, and two important terms that we have covered is there are two, which is verification and validation. Now, make sure that this term is not to be confused. Verification is basically similar with what have been mentioned before, which is to conform to its testing. Okay, validation, on the other hand, is related to identify whether the system which is already ready is it meeting what the users requires. And then we have seen that when we are doing verification, we have covered the first part of the slides, which is there are two methods for verification. One is software inspection. So software inspection is basically checking perform on the documentation related to design, analysis, testing, where that's why it is being called static verification, because it is being performed without running the system. And the second one is software testing, whereby you can actually exercise the system, running the test cases, and you are able to observe how the product behave. All right, thank you.